All right, let's jump right in. You ever stop and think about how a self-driving car knows that's a stop sign? Or, how your phone camera just instantly finds all the faces in a photo? Well, that's not magic. It's an incredible piece of AI called object detection, and that's exactly what we're breaking down today. We're going to look at how we teach machines to see the world, not just as a bunch of pixels, but as, well, a world full of things. I mean, for you and me, it's just second nature, right? We look at this picture, we see a dog. Instantly. No thought required. But a computer? To a computer, that's just a massive grid of numbers. Literally, just data representing colors. So the big question is, how in the world does it learn that this specific pattern of numbers is a dog, and say that pattern of numbers is a truck? That's the fundamental problem we're trying to solve. Okay, so we're diving into section 1, seeing like a machine. And we're going to tackle the core challenge of computer vision. Like I said, the answer isn't magic. It's this really powerful field of AI that we call object detection. This is the tech that actually gives a machine something like a sense of sight. So what is object detection, really? Well, it boils down to two main jobs. First, you've got classification. That's the what part. The machine has to figure out, is this a dog? Is it a car? A person? Then, and this is just as important, you have localization. That's the where part. It's not enough to know there's a dog in the picture. You have to know exactly where it is. So you draw a little box around it. You absolutely need both of those pieces to give a machine real vision. All right, next up, meet YOLOv5. We're calling it the hero of our story because, honestly, it kind of is. So, how do you solve this whole object detection puzzle efficiently? Well, this is where YOLOv5 comes in. It's a game-changing model that's gotten super popular for two really, really good reasons. It is ridiculously fast and it's tiny. And look, when I say fast, I really mean it. We're talking up to 140 frames per second. To put that in perspective, some of the older, more traditional models, they struggle to even hit 5 frames per second. So this isn't just a little bit better, it's a complete leap. It's the difference between looking at a single static picture and being able to understand a live video feed as it's happening. That's real time. And if the speed wasn't enough, get this. The whole model is just 27 megabytes. That is tiny. And that right there is a total game changer. Why? Because it means you don't need some huge, expensive server in a data center to run this thing. This AI is small enough to run directly on what we call edge devices. We're talking about your phone, a smart security camera, maybe even a small drone. That's huge. And maybe the best part of all, it just works. Right out of the box, you don't have to train it from scratch. YOLOv5 comes pre-trained on this enormous data set called COCO. We're talking hundreds of thousands of images. So the second you download it, it can already identify 80 common object classes. You know, things like people, cars, stop signs, dogs, the stuff you see every day. Okay, so that brings us to the big question. How does YOLOv5 actually see? Let's take a peek under the hood. Now, it might sound super complex, and, well, it is, but we can break the main idea down into 3 surprisingly simple steps. So here's the basic recipe. First, instead of trying to look at the whole picture at once, YOLOv5 chops the image up into a simple grid. Think of it like a chessboard. Then, for each little square in that grid, it uses something called anchor boxes to make a quick first guess about what might be there and what shape it is. And finally, there's a really clever cleanup step called non-max suppression, which basically gets rid of all the duplicate guesses so you're left with just the best, most confident answer. So, let's talk about those anchor boxes. What are they? The easiest way to think about them is like a set of stencils. The model has these predefined box shapes that it starts with. Maybe a tall, skinny one that's good for spotting people, and a short, wide one that's perfect for cars. It uses these as a starting guess, and then the AI learns how to stretch and resize those stencils to perfectly fit whatever object it finds. It's a really smart shortcut that helps the whole process run so much faster. And that brings us to the final cleanup step, non-max suppression, or NMS for short. This is so cool. On the left, you can see what the model's first draft looks like. You've got a bunch of different boxes all trying to point out the same dog, each with a slightly different opinion and confidence level. It's messy. NMS is the process that cleans that all up. It looks at all those overlapping boxes and says, okay, which one is the most confident? And it throws the rest away. The analogy is perfect. It's like having a whole crowd of people pointing at the same thing, and you just decide to listen to the one person who's yelling the loudest and seems the most sure of themselves. You're left with one clean, confident answer. Okay, enough theory. Let's put the code to work and see how we can get from all that theory to a real result. Now, you might be thinking this sounds like it's going to take hundreds of lines of really complicated code to get working. But with YOLOv5, you're in for a surprise. It is shockingly simple. No, seriously, that's it. That one line of code you see right there, that is all it takes to download and load the entire powerful, pre-trained YOLOv5 model right into your project. With just that one little command, you've essentially just installed an advanced AI brain that's ready to start seeing. And what happens when we feed it an image? Let's say we give it this picture with a truck and a dog. Boom. This is the kind of output you get. It doesn't just see pixels. It tells you, I see a truck, and I'm 92% sure, and I see a dog, and I'm 88% sure. It really is that straightforward to go from a simple image to a structured, useful piece of data. Okay, let's talk about training for the real world. Because identifying common objects is cool, for sure. But the real power, the magic of YOLOv5, is that you can teach it to see whatever you want. You can train it to recognize custom objects that are specific to your job, your industry, or your unique problem. Just think about it. Imagine a telecom company. They could take this model and teach it to identify their own specific equipment. Things like routers, switches, servers, all the gear in their data centers. A technician could just walk in, snap a photo with their phone, and the AI could instantly take inventory of everything in the room. How cool is that? And you know what? The process for building one of these custom models is actually pretty straightforward. It's really just a 4-step workflow. First, you have to annotate your photos. That just means you draw boxes around the stuff you want the AI to learn. Step 2, you create a little configuration file to tell it what it's learning. Step 3, you run the training command, you hit go. And finally, step 4, you deploy your brand new custom model. It's a very clear path from idea to a working AI solution. So let's zoom out for a second. The future is in sight. Why does something like YOLOv5 matter so much? What's the big deal? Well, what we're looking at is a turning point, really. This is the moment where super high-performance computer vision stops being a purely academic thing and becomes a truly accessible, practical tool that anyone can use to solve real problems. So, if you're going to remember anything, remember this. The key insights are right here. You get that insane real-time performance, you get the tiny size that lets you run it on small devices. It's built from the ground up to be customized for your own projects. And it's simple enough that you can test out your ideas really, really fast. It's that combination, the speed, the size, the flexibility, that makes it an absolute powerhouse. And that really brings us to the most exciting question, doesn't it? We've reached a point where we have these incredibly powerful, incredibly accessible tools that can give machines a sense of sight. So the question isn't, can we make them see anymore? We can. The real question now is, what should we ask them to look for next? What problems do you think we should solve now that our machines can finally see? The possibilities are quite literally endless.